In the previous video, we looked at the formula for angular speed. In this video, we will take a look at the linear speed of a point on a belt or a tire. The linear speed is equal to 0.1047 multiplied by the speed in revolutions per minute multiplied by the radius in feet or meters. 0.1047 is a constant, but is a correction for units, since 2 pi radians is equal to 1 revolution divided by 60 seconds, which equals 1 minute. Linear speed in our class will have units of either feet per second in the English system or meters per second in the metric system. Let's take a look at an example of finding the linear speed. The wheel on the same motorcycle as our example in the previous video has a rolling radius of 1.2 feet. We want to find the linear speed of a point on the tread of the wheel. Here we are finding linear speed, which is equal to 0.1047 multiplied by the RPMs multiplied by the radius. We found in the previous video that the angular speed is 562.5 RPM, and we know that the radius is 1.2 feet. Multiplying, we see that the linear speed is 70.7 feet per second. Now we want to find the speed of the motorcycle. We know that the linear speed is 70.6 feet per second. All we have to do in this problem is convert units from feet per second to miles per hour. We know that 1.47 feet per second is equal to 1 mile per hour from earlier in this course. We will put 1.47 feet per second in the denominator and 1 mile per hour in the numerator. Dividing, we see that the speed of the motorcycle is 48 miles per hour. Now that we know how to find both the angular speed and the linear speed, let's compare the two. For points A and B on the circle, they both have the same angular speed, which is measured in revolutions per minute. However, their linear speeds are different. The linear speed depends on the radius, and since the radius of point A is smaller than the radius of point B, point A has a smaller linear speed than point B. There are several examples where you have probably experienced linear speed versus angular speed. In a marching band, when you are turning a corner, your line needs to stay straight. That means the people on the outer side have to walk faster in order to turn the corner, since they have a larger radius. As another example, for a given angular speed on a bicycle, the bigger the sprocket, the faster the chain moves. In the next video, we will look at rotational power.